Ignition. Yeah. Hey, welcome everybody to Astronomy Daily Live. This is for
And
the
liftoff.
yeah, we have liftoff. So this is for the 6th of May, 2019. It is 2 hours UTC, and it's time together to gather together and just chit chat about astronomical things and science things and who knows what else. We like to focus on those things mainly, but sometimes we can go off into other directions. Who knows? Who knows? So, but mainly astronomy, space, sciencey things, all that. Hey there, Ray. Here for a few minutes. Cool. Howdy. Nice to see you in the chat. Thanks for checking in. All is well here. It's cloudy. We got those high clouds here, and they've been actually around for several days. Just these high, thin clouds that make uh, make doing any serious science with the telescope impossible. Impossible. But yeah, been away a couple of days. The yesterday at this time I was in a sweat lodge, a local sweat lodge, and those are always nice. They're nice at many levels, and so it's always nice to get really warm like that too. So feels really nice. It gets that warmth all the way down into your bones, and it's quite nice. So yeah, everything went well there. A good time was had by all. It's a nice way, to reconnect with friends, and those kinds of experiences are these shared experiences that I talk about, and yeah, when you when you sweat with someone, um, you definitely form an interesting bond there. So yeah, let's see. So 9-inch colas. Hey, nice to see you, Page Master. Hey, nice to see you, Tom. Excellent, and Chuck. And on the panel once again, Bobby. Hey, what's going on?
All right, doing good here. And Ray, within the last 36 hours, only had 3 hours of sleep.
You only had 3 hours of sleep in 36 hours. That
Yeah,
sounds like astronomer stuff. So
yeah,
yeah, I gotcha.
yeah. And thank you, Ray, for looking at my videos with the digital stuff.
Yeah.
Yeah.
I've
And
checked out a
especially
couple of those too.
and speaking of one that does digital stuff, the digital modes and stuff, from what I have been hearing, so what I have been hearing was that I think that it's gonna it's so what it is. One of my shows that's been doing the digital modes and stuff. It's going to move from 5850 kilohertz to 9395 kilohertz, and it's going to start at 0130 UTC, and it's going to end at 230 UTC. So the confidence of me being here on a Wednesday will be probably be low.
Pretty low. All right. Well, we will keep that in mind. It's I welcome everyone into this because astronomy is so broad and huge and everything else. It's
Alert.
super easy. Hey there, Mr. Ert. What's going on?
Hey, just checking in. How you doing?
Good. Everything's good.
All
We had some
right.
clear skies yet?
Not yet. We got clouds tonight and some rain coming.
Oh, come on now.
Yeah,
Come on.
I know.
Man.
So that's the
Well,
thing. that's the thing about the Midwest. It really kind of unstable air as far as the upper atmosphere is concerned.
Yeah, yeah.
I
We don't
wonder.
get the,
I wonder how bad the river still is and stuff because it's still pretty darn high for last time I checked.
Oh, it's high here. We got it's going down. It's going down, but we still have high water here.
Oh
Yeah.
yeah.
So, but nothing major right where I'm at. So that's a good thing. So,
Yeah, I think I got nothing to be too concerning for me as of yet and stuff.
yeah.
well, and I have absolutely no water whatsoever.
Except for in your glass, right? Just in your
Ex-
glass.
except
That's
what
it.
comes out of the ground.
That's
Yes,
right.
yes, sir.
And
So
I got my water right here.
great.
So Ray has lots of floating in the field miles south of his location in southern Illinois.
Wow. Yeah, that's it's here it was a very unusual winter, and it's turning out to sort of be an unusual spring too. You know, one of the things that we like to advertise here is one, how dark it is, but also how often it's clear. And I got to tell you, this since November, December or so, and maybe even before that, it's been unusually cloudy, a lot, and it's these high thin clouds that
Mm-hmm.
are semi opaque, so you can sort of see through them. But if you want to do any kind of science, no way.
You can do
Absolutely no way.
do science on the clouds.
You can do science with the clouds, absolutely. Yeah,
Yeah.
Mm,
but so
So
yeah, it's been a little unusual, even here.
yeah.
yeah.
Yeah, so Ron, I was telling him about that we was able to make the bots work and stuff, and I
Oh
know
yeah.
you've been working it kind of like a bit different. That wasn't the way how Hayden had it and stuff. How you was still able to do it that kind of way and
Okay,
not
I
this
was
way?
okay when you created that Vixera, and thank you for that by the way. When you created that, that gave us the opportunity and the go ahead on to be able to actually do that connection. So what happens is you can actually if well you if you're wanting to share music, you don't have to be on Earth Radio to share. You don't have to be on the radio part of it to share the music. You can share your own music right on that channel.
Yeah,
Okay, so like if you have some kind of audio you want to share and you want to stream it live over, your desktop audio, whatever, right over the Earth Radio channel, as long as I'm not using it.
yeah,
Um, uh,
um, yeah.
Amanda's gonna go on in about 30 or in about 20 minutes, I guess, at
But what
10.
I
Or,
was talking about is you do it vastly differently as compared to what Hayden had it,
oh, I'm
and he was
not.
able to make it work then.
I'm getting it to work though, so that's really. I'm just happy it works. So I'm just glad that I can stream the audio over when I play music or when I play
Now,
anything on my station. So I like doing that.
what browser you use? I use Chrome.
I
I was
have
wondering,
Google. I'm using Google Chrome. Yeah.
okay, because Rob, when you do your F12 and you go to the network session, and let's say you just refresh it, and you see something that says media. You right click on that, tell them copy the link address, and then use your Backstore or Groovy or something to play your stream.
Oh, on the okay. What I do on the you have to go to. I have to be signed in as the operator of the station. Okay. So
Okay.
then I go and I highlight the tiny URL it's called, and it's just a link address for the station, and then I use that to play it. So
Okay. Oh
Yeah.
wow! I didn't know you got that advantage with since you're the
Yeah.
station manager.
Yeah. You have to be actually signed in as me. There are a few people that do that, already. And so, I mean, if a regular DJ that I have, like Amanda or Johnny or Chris, any of them can do that. So, I would encourage them, if any of them are gonna do a show, I would encourage them to actually
Okay.
air that
Wow.
live on
Well,
Discord.
that's that like puts a even more lesser load on me because you got that advantage. And what's also good about that advantage is you can just go ahead and just push it to the Discord.
Yeah, and then what you could do is alternatively, if you're listening, I think you can stream like what you've been doing. You can stream the audio directly to it, I believe, just like how you were
Okay.
doing before. Now mine is direct. Mine is direct connection. No, mine is not a relay or how you were doing it. Okay, mine is a direct connection of the station. So that's set up. So
Okay. Okay.
okay.
That's very, very nice. So you need me to try to set it up for you when Amanda goes on, or you don't need me?
Um, no, you can just listen if you just want to go ahead and relax and sit back and listen to it. And
Uh,
I want you to listen if you want to listen to some comedy. That'd be awesome. And
yeah.
come on back and come on by and check it out. And when you're done with Cosmic here, and then we can have some laughs. And Sunday night is always fun for that at 10:30. She might not
Yeah.
do it the next. She might not do it the next couple of weeks because she's gonna be in New York. So,
Yeah.
next
That
couple
that
of
that
weeks.
tie bush thing.
Yeah, that's right. So that's going to be kind of busy for all of us. We're going to be kind of distracted and taking uh, advantage of that opportunity to be visiting with each other, and we should be able to do a couple of shows, but pretty much Earth Radio is going to be on a vacation time at that moment. So I might have somebody. I think Johnny is going to do some shows for me, and we might do a couple of live shows while we're there. But
Yeah.
So
I
what's
won't be.
this? What's this
Go.
event?
It's called the Pine Bush Paranormal UFO Fair.
Hmm.
It's an
Okay.
annual event in Pine Bush, New York, and Bill, the producer Bill, he actually puts on Bill, New York Skywatcher. He actually puts on, or he kind of is the curator or the manager of the event, and so he gets all the guests, he gets all the people going to go and speak. He get, and now he has the power of KGRE producing staff to help with promoting it and getting it going. And
Oh,
so he has some other people that are on his team as far as giving him some power and some strength to get some things done and get more
Yeah.
people in to talk. We have lot of different big names. If you go to the parent, I don't know what that site is. Bill would obviously know it right away. I don't remember what that site is, but Pine Bush Paranormal UFO Fair. You can probably do a Google search on it. And Pine Bush, Pinebush, really is it? And just look it up on Google, and it should come up top of the thing. And it's an annual event. And so what Bill does is he has a lot of us. That's what myself and Charles are going to be doing. We're going to be going there, and Amanda's going to be there, and a few other people are going to be staying at Bill's house.
Hmm.
So Bill opened up his house to allow people to come on and stay over there, so they don't have to pay for the hotel and things like that.
wow,
You know,
pretty
and
nice.
then makes it really nice. And Bill does the cooking. Him and his mom, they kind of argue over the cooking, but Bill does pretty good on his own.
Yeah.
And yeah, and then some of the other people that are there, that are going to be there, they know how to cook too. So no worries about eating there.
Cool.
So, but yeah, it's a lot of fun. Last year I drove there all the time. That's why I got there, and there was a tornado there when I got there, and that was just messed up. Everything was messed up, and the event actually got postponed to June. But we still had an event of our own. We had people come and talk, and still had a bunch of people at his house for a week, and we had 4 days without power because everything was down. The lines were down, everything was offline, and no cell phone. He had a generator that was running the thing. I was able to do some live streaming. Somehow I got a phone signal after the second day or whatever, and I was able to do some live streaming of the mess and the different things. And he was trying to cut a tree down off of his roof.
Wow.
So yeah, a lot of fun stuff, but hopefully no weather like that. Hopefully no weather stuff like that. So
yeah,
we'll have clear skies and clear nights and a lot of fun with getting to meet all these important people we have coming out. And Amanda from Canada will be there.
Yeah, cool.
So, and I've been talking to Amanda for a little over a year now, so that'd be fun to meet her for finally, and so.
Yeah.
And be fun to meet some of the other people that I've been talking to, on social media and stuff like that. And these are all people that are involved with the UFO thing and astronomy and things like that. And
sure,
there's a lot of really neat people. And it might be something you might want to consider in the near future, that if you want to do like a talk on whatever you're talking about, whatever you want to talk about.
Yeah.
You pick a subject. You pick a subject what you want to talk about. You talk to Bill about getting it set up, and next year if you can take time off to take a trip out there, it's a lot of fun.
That's pretty fun. So.
It's a lot of fun. I mean, you just take a week, you forget about life for a week, and you just have a good time. And you can still talk about what you enjoy, and you're around other people that are thinking the same exact thing what you're talking about.
Yeah,
and no one's arguing, no one's trying to prove a point, no one's trying to be smarter than anyone. It's just like here, everyone's equal here. Everyone's enjoying what we're talking about.
Yep, absolutely.
And that's how it is at his house when everyone's there, which is amazing when you think about how many people are there, and just amazing how everyone is getting along and working together and just having a fun time.
Nice.
So, just a thought you might want to consider.
And hopefully trying to get to the bottom of sort of a mystery. We're trying to understand what's happening, why these people are having these experiences, and it'd be nice to sort of get to the bottom of that.
Oh yeah. Yeah,
let's move on.
We're getting little bits and pieces of it, and we're kind of understanding some of what's going on, but there's still a lot of loose ends we got to figure out.
Yeah.
And, that's why we have these events, and that's why we try to get to help people become aware of what's going on. I don't think I ask for anybody to believe anything. I'm asking people to be aware of it. Think about what we're doing. Whether it be astronomy or UFOs or whatever we're talking about, paranormal, it doesn't matter. Just be aware of it and then research it. Do your own investigation, and don't be afraid of it. Don't shut it off and say, okay, it doesn't exist or it's not there. That's not the way to deal with it. You try to investigate it, and you try to evaluate it in your own mind. And then you can share what you know and what you learn. And if you have an experience, share that, And
absolutely. And curiosity is really, really, really important. So yeah.
Your cats have a lot of it.
What's that?
Your cats have a lot of curiosity.
Oh, they have taught me curiosity. I mean, I already was, but they are experts.
Oh yeah, there you go.
Yeah.
Sorry to take up so much time talking about that, but
no, it's good stuff. it is really important not to shy away or you dismiss, you know, these kinds of mysterious things. You know, I mean, I think a lot of people, you know, they form, you know, some pretty rigid beliefs pretty rapidly. But you know, there are many of us who can, you know, keep the open mind and not worry too much about, you know, if this is a little too weird or you know, it's completely, you know, bonkers, whatever. Yeah, you know, you got to keep an open mind about things and sort of appreciate people's experiences because
Oh
they're
yeah.
all different and they're all unique. They're probably all pointing to, you know, more or less the same truth, whatever it is. Um, and I always make the assumption that there really isn't anything, you know, malicious or you know, harmful. You know, I sort of go with the assumption that, you know, people are, you know, investigating this um, uh, in sort of a way that you know, is going to reveal a mystery at some point. And I don't think, you know, I mean, maybe there are some secrets. I don't know that. As I've said many times, you know, I've been privy to some secret things, and uh,
Yeah, I have the
all the
suggestion.
ones I
Yeah.
was like, really, is that, you know, does that really have to be a secret? That
Right.
seems kind of
I was
dumb.
gonna say
So
that some of the secrecy could be just the unknowing, you know, the not knowing of what you're really talking about, and so
yeah,
then you create a secret even in your own mind, possibly, you
right.
know, and then obviously we're missing some parts of the information, so it does appear to be a secret. So just keep that in mind that you know you have to evaluate these things 100%, not just halfway. Okay, so you know keep that
And
in mind.
speaking of masonry and secrecy, I don't know when that happened, but Patterson is the next town over going like westbound. If you go like throughout Main Street, um, I don't know when it happened, but there used to be a Masonic lodge there,
Hmm, okay,
and I don't know what happened and stuff, and then they're trying to sell it.
Hmm. Yeah, we
interesting.
gotta. I mean, I don't know, and I really don't care anything about that. But there's a Masonic lodge in one of the nearby towns near me here. Yeah, I mean, you know, it's just a club. So
Yeah.
um, yeah.
Yeah,
Anyway,
and I think there
I've been
is
seeing,
one more in still in Patterson, but it's at the Martin Luther King Boulevard, if I
hmm,
recall correctly.
I've been looking at the chat and thoroughly enjoying Tom's comments about Alan Shepard. This day, 1961. Um, I don't know, you know, I don't know if he exactly made it into space or not. Um, you know, that's sort of a blurry edge there. But you know, he was definitely the first American to you know, ride a rocket and you know, do that daring, uh, crazy feat. So yay, um, and yeah, right. I totally agree. I think The Right Stuff is a pretty good movie.
Yeah.
I really like the first part. Um, you know, once all the astronauts are picked and all of that, you know, it's sort of like, well, you know, that's, but Chuck Yeager's story and what sort of led to the picking of the first 7 astronauts.
Oh yeah.
Just a epic story, right? Just absolutely insane. And it's funny, they had to think about what kind of profession would be most skilled in being an astronaut, because it was like a new thing. And I don't know if the movie fictionalized that a little bit or not, but they looked at circus actors and I'm trying to remember, just bunch of different professions, and the military won out. I'm not too surprised at that. The military was really the only entity that was capable of rocketry and all that. They had the money to do it. They have the technology to do it. So the military won out. But yeah, for those who haven't seen The Right Stuff, the only spoiler I'm going to give is that it's long, right? It's long.
Yeah.
Is it 3 hours? I don't think it's quite 3 hours. Trying to remember exactly. I think it's pretty close to 3 hours, I think. But it's a great movie, great actors, great acting. The
And then
writing.
you have to remember too, when they made that, they did not have all the fancy fun stuff that we have today with the technology on the filmmaking.
Oh, and I am so disappointed in CGI for the most part. It looks like Mickey Mouse to me. It's just
right.
It's really, really, really bad. I think so far the best CGI that I've seen, and I don't watch movies, so I'm not going to be a good authority on this, but the landscape in Avatar was looked like the real deal, right? Now all the characters and all of that, they look like silly Mickey Mouse things.
Oh yeah.
But the landscape, the rocks and the waterfalls and the trees and all of that looked really, really, really nice. So I don't know what it is about doing animations of like living things that the CGI folks just can't get. They just can't.
They're missing something. Yeah.
There's something wrong, and maybe they're doing that intentionally. Maybe, because they, maybe there is some kind of a rule that says, don't make it look too real, right?
Right.
Yeah.
I don't think so.
And, all right. So, Pagemaster was a blockbuster flick back in 1983, but became a cult classic. Was nominated for 8 Oscars,
Mhm.
and it has a 3 hour and 12-minute running time.
Well, there you go.
All
right, well,
Okay.
I gotta go.
3 hours and 12 minutes. Wow.
Yeah.
Yeah.
Yeah, take your run.
I gotta go, guys. Thank you.
Okay.
Cosmic. We'll talk to you guys later.
Yep. Have a great radio show.
All right. Bye bye.
Yeah.
Bye.
Okay.
Bye.
So.
Yeah, so
Okay.
See that movie. Make sure that you get the unedited version. The edited version cuts out a lot of stuff, a lot of really, really important stuff to the story. So make sure that you get like the director's cut or the long version, because you don't want to miss any of that. It's great.
Yeah.
It's great.
Yeah. So Pagemaster says there will be a second Avatar movie in 2020. Now there is a concern about Cosmos 3. When is that supposed to be released?
I'm not exactly sure. I haven't really been following that. So I honestly don't know. I know that somebody up here was talking about that.
Yeah. And
Yeah, the spring. So,
how much do you know 90s gaming consoles?
absolutely none.
Ah, crap. Then you're going to be missing out because I heard that Paramount and Sega is going to do a Sonic the Hedgehog movie. So if you was a great Sega fan, Sonic the Hedgehog may be good for you.
Oh, well, like I said, I'm not really that much into movies anyway, and I've never been into video games in any
Yeah,
way at all. I'm a pinball guy, right?
yeah.
Give me a
I
pinball
I
machine.
got turned
I'm
off
in.
of games since I sold my Nintendo 64 so I could have money for my senior homecoming dance.
Oh, okay, all right. Well, that's a pretty good trade, I suppose. Maybe, but yeah, no, I've never been into
And if I
games.
recall correctly, Chuck Nagrum, um, I think Jim Carrey is going to play Doctor Eggman on that movie.
Hmm. Yes, pinball machines from the 70s and 80-ish or so. Yeah, yeah, the old ones, right? The old mechanical ones. Yeah, awesome, awesome. So yeah, and those
Okay.
don't count as video games. Those are something else.
Yeah. And Tom, what Sega did you had? You had like the Sega Master, the Sega Genesis, or like the Saturn or the Dreamcast? What kind of console that you had?
And I've never heard of Sonic the Hedgehog. Never heard of it until this moment. Is
Yeah.
that a
Wow, Sega Genesis. Wow. I think of all the gaming consoles of all time, the Sega Genesis has got to be on that number one of so many of those great gaming consoles that we have in the past, present, and future.
huh, all right.
So thank you,
Well,
Page Master. November 8th, Jim Carrey will portray as Dr. Robotnik.
Dr. Ivo Robotnik. That's
Yeah,
great.
Dr. Robotnik was the evil character in the Sonic the Hedgehog games.
He sounds very, very evil.
Yeah. So,
Robotnik.
but I
That's
was
great.
more into Nintendo, so I would know like Mario. Um, so at least Mario, Tetris.
Hmm.
Um, let's see, what's another good one? I think the only one that I know is like Mario, Tetris.
Cool.
Um, let's see. I'm trying to think. I know Mortal Kombat was on Nintendo.
Huh,
Final Fantasy was another one. Uh, my mom used to remember the Atari 2600,
huh,
and she would like remember games like Pitfall, some form of racing game. I forgot the names of
huh.
almost all of them. Donkey Kong. Thank you, Page Master.
Donkey Kong.
Donkey Donkey
That
Kong, another good game.
that one I've heard of at least. So,
Yeah.
but yeah. Oh wow. So Elvira, Mistress of the
Zelda.
Dark.
Zelda. The
Zelda.
Legend of Zelda was another great one.
Oh, all right.
And I think
That
Zelda
one.
came either before or at the time of when Mario Brothers first came around.
Hmm. Well, Ray, that was a very, very good deal on all of those. So, What year did Elvira, Mistress of the Dark, come out? That to me would be a pretty recent one, maybe the 90s or so. But you can remind me if you know. But
Yeah,
yeah,
I
one
kind
of these
of
days.
remember that when my local Walmart used to have an arcade, like in the store, and I
Wow.
would go in and I would love to play Crazy Taxi.
I've never heard of that one either.
Yeah. So
It's in 1988. Okay.
yeah. And I used to play they called it skeet ball, where you just throw it and it's got to go into those scoring
Oh yeah,
mechanisms.
yeah.
Yeah.
Cool.
Um,
Cool.
have you, out of my curiosity, I've seen a video about someone was playing skeet ball, and I think some kid was looking at it, and I think it was a girl that was playing it. I think she did it too rough or too high, and it bam hit the kid's head.
Oh, that's not very nice.
I know.
Wow. Yeah. You got to be careful with skeet ball. Yeah,
Yeah,
for sure, for
yeah.
sure. All right, well, cool. Let's do some astronomy here. I think I want to continue with our long-standing object of the day. It's NGC 6397. This really interesting globular cluster down in the constellation of Ara or Era. I'm not quite sure how to pronounce that. Just west of Scorpius, and there are like 1,746 references, papers that supposedly talk about this object, and that's an unusually high number. And so far, the only sort of unusual thing about this globular cluster um, is that it seems to be the closest one to us. And that has a lot of advantages because, uh, the closer these things get, the better we can see individual components. And if we can see the individual components, then we can make various measurements on them. We can measure their brightness and see if the brightnesses change over time. And then we found, some variable stars, or you can look at the spectra of the individual stars and see if there's anything interesting there in terms of composition or temperatures or luminosities. Um, having an object like that, relatively close. There's, I think, a lot of dispute in terms of how far away it is. It's not hard. It's not easy to measure distances. It's very difficult. The frustrating thing about that is that distance is pretty much the most important parameter, because we base everything, all of our models, all of our theories are based on distances. Um, and so, it's like, um, uh, you know, if we're not able to measure these distances well, then all other things are going to be way off too. But it's like the hardest thing to do. So to have one relatively close, this one, I think, they're clocking in somewhere between 7,000 and 8,500 light years or so, which like I said, for a globular, is pretty darn close. But I just sort of thought that we could just keep looking at a few of the references and dive in and see, why people are so interested with this object. so last time, we looked at a paper that had identified a whole bunch of variable stars. So they looked at sort of the outskirts of this cluster where there are fewer stars. With the I think they used a telescope down here on Earth. I think it was the some European Southern Observatory telescope. I forget which one. And they found quite a few new, very, 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 very faint variable stars that are members of this cluster. So very, very cool. So yeah, let's just keep going with. Excuse me. Going with that, and let me share my screen. We'll just take a little bit of time here to see what's up, what additionally is up with all of that. Oop, I gotta go here. Oop, that. So here they're talking about the white dwarf population. So that is pretty nice. That's a particular population of stars. White dwarfs are pretty interesting objects. They're sort of evolved stars, at least this is the story, that they're sort of evolved stars that are now sort of at the end of their lives, but they're just slowly cooling off, and it'll take quite a while for them to cool off. They're roughly about half the mass of the sun and about the size of the Earth. So they're really dense and pretty interesting. You look at the spectra of these things, and you mainly see hydrogen and helium, and that's it. But in a number of these, you're starting to see other things too. You're starting to see some of the heavier elements. And of course, there's a question as to why. So anyway, let's take a look at this guy, this paper. Out of the astrophysics data system, always a great resource. So ADS is hiring a front-end software developer. Hey, I should apply. Let's see.
Hope it's one of those in-home jobs, that's for sure.
Well, it's the only way it would be. That's the first question I ask. It's like, do I have to be there, or can I work from home? Well,
That's
they
it.
give one of those answers is the right one, and one of them is the wrong one. So NGC 6397 is one of the most interesting, well-observed, and theoretically studied globular cluster. White dwarf cooling sequences. Cool.
And we're going to say goodnight to Ray.
Hey, Ray.
And now I think what you can do, Ray, is put some ambient that's gonna make you go into a deep sleep. I think you'll definitely love that.
Yeah, I don't think he is going to need that from what he's saying. He's about ready to fall over. So yeah, take care, Ray. Thanks for coming in. Come on in anytime. So let's see here. Present a population synthesis study of the white dwarf population of NGC 6397. Study the shape of the color magnitude diagram. Yay. Okay. So yeah, we've looked at a number of color magnitude diagrams. It's just, well, we'll get to it. I'll talk about it again a little bit. Repetition is a great way to learn. All right, so let's see. I'm just kind of interested in seeing what they found and sort of how they they found it. They're probably going to go into a lot more detail in terms of modeling and all of that, and that's just a little bit harder to go through live. That's the kind of thing that I would like to study a little bit, so I can talk about it relatively intelligently. But usually, if we look at the pictures and stuff, yeah, we can get a relatively good idea. So let's see. Second largest globular, second nearest globular to the sun. That's what they're saying here. Thoroughly observed by HST. High quality deep images that have allowed us to study not only the lower main sequence, but also the white dwarf cooling sequence. Is old and metal poor. Okay. So you can sort of see what ages we're sort of dealing with here. These are old objects. The theory says that our universe is about 13.6 gigayears old, and some of these things, are actually exceeding that, with some pretty large error bars. So that still fits the story. But yeah, these are very, very old objects. They formed about the same time the galaxies did, and the galaxies have been around for quite a long time. We also have luminosity function. That's allowing to investigate in detail. So luminosity function is one of those things that is dependent on distance. If you don't have your distance right, then your calculation of luminosity, or how intrinsically bright the object is going to be off. So, but this implies that they have a pretty good sense of distances as well. And Gaia has parallax measurements of a lot of the stars within this object. We saw that the other day, and if you can get some sense of parallax, then yeah, you can directly calculate distance. So, all right, very cool. So yeah, I think from here on out, they're just going to be talking about their models. But yeah, let's see if there's some color magnitude diagrams here. Here we go. Let's see. So these are, okay, that's kind of interesting. So yeah, here's sort of your typical color along the x-axis and magnitude along the y-axis. And you can see that they've measured the brightnesses of these stars with two different filters, so-called F606W and F814W. The 606 and the 814 is probably pretty close in nanometers to what the wavelength is. So they've taken these brightnesses and subtracted them with a magnitude scale, of course, and then compared that to the F814W magnitude. Now you can see these are really, really, really faint, especially at 814 nanometers, which is very, very, very red, right? Very red. You would expect these values all to be positive. Do we? Let's see. I was confused this, but I'm going to talk through it again. So if this value is positive, which they are, looks like all of them are, that means actually that 606, the magnitude value, is larger than 814, which means in the magnitude scale that 814 is actually brighter than 606. To me, that doesn't make a lot of sense, but that's what it's saying here. So I would expect these to be negative. I would think that they would be brighter in, at 606 nanometers because they're white dwarfs. But maybe this is just the whole. Oh, okay. So this is just for the whole cluster. Okay, that's why. Because most of the stars are red, and that makes sense now. The 814 is actually brighter than 606, which would make these values all positive. All right. Now, you just got a glimpse inside of my wacky mind there. Let's see. Okay. Well, cool. Let's zoom out here a little bit. Trying to see what these, see all these gray dots up here. I didn't see that until just now, but let's try to find out. Okay, so the black dots correspond to white dwarfs, apparently. Wow. Red points are the results of their simulations. Green squares. Okay. Blue thin lines correspond to that. Yeah, but what about these? Oh, okay, here. Gray dots are the main sequence stars. Okay, so they're way out there. Interesting. I would think that these would be brighter at shorter wavelengths than the other way around. I have to think about that a little bit, I guess. See if there's anything else. Role of residual nuclear burning. Same as figure 1 with no residual hydrogen burning. So, that has to do, I would think, with the models. The data is not going to change, but maybe the models change a little bit. Yeah, it's kind of hard to tell. Oh, come on. There you go. Okay. Clean white dwarf luminosity function. Okay. So these are the magnitudes, and this is the mass. The mass of the white dwarf versus the magnitude. That's kind of interesting. There's a relationship there. Makes sense, I think. Brighter it is, the brighter it is, the brighter it is, the less massive it is. Let's see. Okay. Wow. Well, quite a paper. That's usually how that goes. Let's keep going this for a little bit. See if we can dig up something else here. Oh, let's go into search. Let's see. Got to get back to where we were. Variable stars. Gamma rays. There we go. Okay, so let's keep going here. The BE test and the lithium rich star, number 1657 of NGC. Haha, okay. Don't know what that's about. That's, yeah, wow. Not quite sure. Lithium flash. I think I've heard of lithium flash, but I don't remember what that is. That might be interesting. Helium abundance in the metal pored globular clusters M30 and NGC 6397. So they're finding helium in these objects. That's pretty cool. Probably not very much, but I don't know. Let's see if they say here. Helium mass fraction turns out to be 0.241. Not quite sure what that number signifies. A mass fraction. Might be able to find out. It might tell us in the paper a little bit. Maybe. Let's find out. Now, I'm not quite sure what that Y value means. Is that that seems to be a little bit high if that's like a percentage or something. So among the few chemical elements synthesized directly the primordial fernax of the Big Bang. Yeah. Well, yeah, I think it is, because as I recall, the theory does say that about a quarter of the matter produced at the Big Bang was helium. So, yeah, I guess that is a mass fraction. Okay, just like it says. Okay. Let's just see if we can get some numbers here. So they were using the VLT. I think that's what that other one was using too. But they're using these multi-object spectrographs, which are really, really amazing. It probably uses fibers, like fiber optics. They can position these fibers right on a whole bunch of stars within the field of view, and therefore get spectra from lots of objects at the same time. It saves a lot of time. So it looks like they're looking sort of towards the ultraviolet. It's still within the visible range, but this would look very, very, very purple to us. Okay, chemical analysis. Lots of talk about the system they were using. The helium content of M30 and NGC 6397. Table 1. Some papers, they put their tables and diagrams with the text, and some of them put it at the end. And I understand sort of the efficiency in writing a paper and putting everything at the end, but in terms of being able to read a paper, it's not a good idea to do that, I don't think. But that's just me. So here's some more color magnitude diagrams again. Here's of NGC 6397.
I think truth to be told, whenever I was still going through Botech in high school, there was always going to be like tables, pictures, and all that during the lecture. You know what I mean?
Yes, yes, it's the same kind of thing, right? I mean, now I'm going to have to go back, back up into the text, try to find out where I was, and that's kind of a pain. Yeah. So here's some actual helium lines, and they can use these shapes, these absorption line shapes. The width and the depth here can tell you how much stuff is doing the absorbing, and so you can have a direct measurement of how much stuff there is. And yeah, it's not very much, right? Here's an absorption line. It's going down less than 10%. And here it's actually less than 5%. So not very much. But we're going to have to go back up into the text in order to understand all this stuff. So it's nice to see, data with some error bars. That's always a good sign. Mass fractions. Yeah, it's flying over my head a little bit, but that's all right. Just looking at color again, looking at the differences in magnitudes. Always a good thing. Not quite sure what these arrows indicate and stuff, but that's all right. Oh, there, we got to the end. Let's see if we can make any sense out of this at all. I doubt it. But yeah, it sort of looks like they're talking about a mass fraction of 0.24 to 0.25. Okay. Yeah, there you go, 0.241. So I don't know if that's a significant finding or not. I think that's sort of what was already known. So yeah, I don't know if doesn't seem like this is much of a game changer or anything. But a confirmation is also a nice thing. So if they confirmed through another means of measurement this helium mass fraction, then yeah, that gives you some confidence in your other ideas. So all right, yeah, okay, pretty cool. All right, let's try to move through one or two more of these, and we can get out of here. There's so much stuff. Let's see. White dwarf population, there's that one. Okay, that's the one that we just looked at. So let's keep going here. Probing mass segregation in the globular clusters NGC 6397. Mass segregation. I don't know what that means. Should we try to find out what that means? Let's see. Go back over to ADS. Pull up the paper and let's find out. So in this study, we present a detailed study of mass segregation in the globular cluster NGC 6397. Carry out a photometric analysis of projected data, luminosity function. So luminosity function shows a higher density of bright stars near central region with respect to the outer region. Oh, okay. Well, that is a little bit interesting. Wow. So they're using a model that has 193,000 stars in it. Wow. Okay. Oldest structures in the Milky Way constitute a valuable source of basic information. Yep. Dynamical evolution. That just, means how are they changing shape and motions and stuff over time. Binary encounters may be frequent, and over time tend to establish a state of equal energy among the member stars. So that might be what we're seeing is just this very, very stable configuration. Don't know. So, and that's kind of interesting, right? That they're seeing that the heavier stars, the more massive stars, are sort of sinking to the middle, and the lighter ones are floating. So, it's the same kind of thing. The heavier things sink, and the lighter things float. Very interesting. Very cool. And some stars even escape. Cool. Mass segregation. Yeah. Huh. The accumulation of massive stars in the cluster may collapse. Huh. Focus of several observational and theoretical studies. Yep. So they put it at 2.2. I think we've seen that number before. Okay. Definitely want to try to pick up that paper at some point. I think we're still in 2014 or so. So I don't think that we have come across this paper yet, but I'd like to see that. I'd like to see how they measured that distance. Yeah. Okay, yeah, they're just showing. So 6,000 parsecs from the galactic center. 6,000 parsecs is 6 times 6,000 times 3.26. So almost 20,000 light years from the center. So yeah, that thing is sitting, 2/3 of the way to us from the center of the galaxy. Pretty cool. Let's see. Kinetic mass of a cluster of about 110,000 solar masses. So yeah, when you look at that cluster of stars, you're seeing at least 50,000 stars, at least. Pretty incredible. Cool. Yeah. So they're seeing heavier mass objects in the center and lighter ones on the outside. And again, they're using the VLT, some old data again, 2009. That almost looks like the same data that we were looking at the other day in terms of identifying variable stars. I wonder if it is, because even the center is the same. Looks like the same data. Okay, so there's their color magnitude diagram. The table 1 images. So the cluster members are shown in gray, and the rejected, filtered out stars are in black. So this gray area are the members of the cluster that they identified, and it's kind of a messy plot because there's so many stars, but yeah, some interesting structure in this gray area. See how there gets a little fuzzy on the outside like that. And they're looking at some pretty faint stars in V, right? They're getting down to maybe like 26th magnitude or so, but they're going all the way up to almost 10th. So that's quite a spread in magnitudes there, almost 10th to slightly fainter than 26th. So yeah, cool. Image slicing, completeness in V. Not quite sure what completeness means. That might have to do with yeah, I think it's just a star count, I think. So yeah, interesting. Using IRAF, of course. Luminosity function. We'll have to get into luminosity functions at some point. I'm going to have to remind myself exactly how to read those. Projection profiles, surface brightness. Pretty good analysis here, gotta say. Radial density profile. Yep, they're doing all the measurements for sure. Cool. Always an amazing amount of work goes into these things. Pretty incredible. So, all right, well, that's just, yeah, well, that's an interesting, I don't know if that's a discovery or not, but pretty cool. Pretty cool. All right, well, I'm noticing what time it is. I think I'm going to get out of here for today. Oh, come back over here. And, yep, it is the doggy alarm. So I think it's a good time to get on out of here for today. So let me check the chat again really quick. Make sure that the shenanigans are going on. Very good. All right, everybody. Well, it is time to go. So have a great evening, a great day. Make sure to subscribe if you haven't already. Thumbs up if you so desire. And spread the word. Spread the word. We're just here. I'm just here sharing a passion for astronomy and space and science and all kinds of nerdy things and just having a good old time. It's very casual and fun. And, a lot of these things are going to fly way over my head and most of yours too. But that's okay. That's all right. There's nothing really wrong with that. A lot of things just take some time to understand, and you have to look at things and think about them for a long time before you really understand them. And that's what scientists do too. That's why it sometimes takes years and years and years or for papers to be written, because it's a hard thing. We're trying to understand stuff, and sometimes it doesn't make any sense at all. That's all right. That's all right. Lots of fun, and yeah, let's keep looking at this object for at least a little while. It's there are lots of interesting things about this object, I think. So yeah, let's dive into this a little bit more, and we will do it tomorrow. One little spin of this planet. All right, everybody, take care. I will see you later. Bye-bye.
Live long and prosper.